So we have an integral here that we'd like to evaluate. And the heading gives away the method that we're going to use. But rather than just walk through the steps from beginning to end, I'm also going to talk about the thought process behind these decisions. At this point, you're probably starting to get the idea that integration isn't as clearly procedural as differentiation is. So getting an idea for the reasoning behind each choice is important as being able to actually implement. So when I first look at this integral, what stands out to me first is that it has two parts, this one and this one, and they're being multiplied together. And the second thing I see is that I can differentiate one of these and easily integrate the other. Now, I could actually differentiate and integrate both of them, but if I can just do one with each, that's enough to make me think that integration by parts is going to be a good place to start here. So the next choice we have to make is which part gets to be u and which part gets to be dv. And this is the part where I see students start to run into a challenge, but there are really only two possibilities. U has to equal either the sine of x or it has to equal x minus 1. Once we've made this choice, we don't have a choice for the dv parts. The dv has to be whatever's left. So in scenario 1, dv would have to be x minus 1 dx. And in scenario 2, dv would have to be the sine of x dx. So now I'll just run through the formula in each of these two cases and hope that one of them gives me something I can work with. All right, so over here in scenario 1, du will be the cosine of x dx, and to get from dv to v, I'm going to integrate both sides, and we'll get v is equal to x squared over 2 minus x. All right, now we've got the formula here, and to implement this, I need to do two things, right? I need to look at uv, and that part is never a problem. We can always take the two expressions and multiply them together. So uv is going to be x squared over 2 minus x times the sine of x minus, and this is the part that's going to either make or break this scenario as the choice that's going to work for us. This is going to be the integral of x squared over 2 minus x times the cosine of x dx. And I don't know how to integrate that. In fact, that really arguably kind of made the situation worse. We went from having a linear factor here to having a quadratic factor here. Right, so I'm not really feeling good about this option at this point. I'm going to set that one aside. Jump over to scenario 2 and hope that we have better luck with this one. So same process. Du is equal to dx, and already I'm feeling a lot better about this. When you're choosing the u part, it's kind of a general guideline, is you want to choose something that gets simpler when you differentiate it, right? And going from that linear expression x minus 1 down to just a constant 1 times dx, that was a pretty solid improvement. Now let's see what happens over here. I'm going to do the same thing on this side with the dv. I'm going to integrate both sides of this, and this becomes v is equal to negative cosine of x. Now let's go to the formula. uv is negative x minus 1 cosine of x. I move that negative out into the front, minus the integral of negative cosine of x dx. And that's a whole lot more manageable. That's something I know what it is. So on this left side, I'm gonna simplify this a little bit. I'm gonna make this 1 minus x times the cosine of x. This is plus the integral of the cosine of x dx. Like I said, I know what that is. So the first part stays 1 minus x cosine of x. This integral is the sine of x, And since all the integrals are now gone, this is the step where I'm going to add a constant onto the end, and there you go. That's the integral of that original expression. So the big takeaway from here is don't be intimidated by the choice of u versus dv. Right? The more you do these, you're going to kind of get a feel for which part you need to be which of the two parameters. But when you're starting off, the integrals that you're looking at, there's not going to be a whole lot of parts to them. So if you need to, you can always just do what I did here, run through all the possibilities, see which one works. So if you'd like to get the full context, you can click on the upper link here to see the corresponding lecture. And if you'd like to see another example, the link below will take you to another presentation that's a little more interesting, since you actually have to use the method twice to get to the final result. So finally, if you like this example or found it helpful, please don't forget to click on the like button below.